At Eaton, we're taking every step to make sure that our models convey enough information to find these collisions before they occur. Some typical interference details not normally found on traditional three-dimensional models could be the required space in front of the equipment, maybe to move breakers in and out, or space that could be required above the equipment for ducts, plenums, or even for outgassing. In a BIM project, if anything runs through that space, collision detection will pick it up. The next two phases, or elements, 4D and 5D, deal with scheduling and cost. Eaton's models currently have parameters for cost. While we don't populate this parameter, it's very easy for a customer or the designer to add that cost in once he obtains it from the salesman via Bid Manager, and then this cost can be used to generate total cost for the project. Lastly, we come to the final dimension, which is 6D, or facilities management. While we believe facilities management and BIM are still several years off, we do believe there is a tremendous potential, especially for aftermarket purposes. However, we also see challenges with the sixth dimension in that to truly be a facilities management tool, it's possible that the manufacturer may have to manage the BIM model for the life cycle of that equipment. Facilitating this would require any changes that are made to the equipment would have to be updated in the BIM model itself, and then the updated BIM model placed back into the Revit project. While we believe this is challenging, it does present some significant opportunities in our aftermarket segment. Let's spend a moment and talk about software suppliers to the industry. BIM is a concept. It's not defined by any single software application. It's actually lots of different applications with the goal of having total interoperability. That means having a standard format so these disparate software systems can share information between each other. One proposed standard is called IFC, or Industry Foundation Classes. Many of the most popular BIM software tools today already support this common file interchange format. For example, Autodesk Revit software and Bentley's MicroStation software applications. But let's take a moment and talk about some of these different CAD packages. I like to put these software or these CAD software packages into three categories. The first being 2D or 3D design software packages. Some of these include the very popular AutoCAD, CAD-Key, and TurboCAD. And these are very basic desktop CAD applications that have a very broad application. Most of these can be used to design anything from chairs to the next space shuttle. The next category are traditional or true three-dimensional 3D modeling software packages. And some examples are ProEngineer, Inventor, and SolidWorks. The first two, ProEngineer and Inventor, are heavily used within Eaton today in many of our facilities, many of our products. Lastly, I want to talk about true BIM software packages. And these are software packages that were designed around this technology. The package that we see the most demand for currently is Autodesk Revit Platform. There are actually two different software packages under this Revit umbrella. One is for architecture, and the other is for the MEP sector. Bentley MicroStation is another true BIM software package. However, we don't see the demand for Bentley that we do for Revit, although Bentley is currently specified in the Corps of Engineers spec for Centers of Standardization. Navisworks is also owned by Autodesk, but it is more of a project modeler. It's not really in a class of design tools. It's in a class of project assemblers. Navisworks will take just about any type of file that is available commercially today and be able to assemble it into a viewable BIM model. Some of the file types that you will see today are the traditional AutoCAD .dwg file type, as well as their very lightweight viewable format, DWF. But what we're focused on for our project, generating two file types, either RFA, which is a Revit family type, or ADSK, which is a very new file format that is also Revit compatible. Both of these file types, RFA and ADSK, are native Revit file types. The IFC file type, as I mentioned before, is a desired standard for common interchange between different software applications. It should be noted that even though Eaton is not supporting a true Bentley file format, Bentley does offer a free download tool that will convert the Revit family types to a Bentley MicroStation format. Now that we've spent some time getting to understand what BIM is, the dimensions of BIM, and specifics about BIM models themselves, let's take a moment and talk about how we can help our customers who are trying to use these new BIM tools. The first thing that we can do to help them is point them to our website that has our new Revit library download. So they can go to our website and download our entire library of configured to order products. And I'm going to spend a little time talking about the difference between configured to order and engineered-to-order products. Earlier in the presentation, we talked about how these models could be parametric. In other words, you can have parameters that can change the physical size of the model. Most of the products that are downloaded in our library have this capability. In other words, when certain conditions are reached in the model, it will resize itself. A good example could be a panel board. As you add a certain number of breakers, the panel board can grow in size. So just by going to our website, customers can get our entire library in one download, and this will plug directly into their Revit application. But now let's talk about the products that don't quite fall into this category of configure to order. Some examples of engineered to order products are low and medium voltage motor control, switch gear, and medium voltage switches. It would be very difficult and potentially dangerous to put models out on the website and have designers attempt to configure a product the correct size. So to get models for these particular products, we're using our own Bid Manager software to generate these models. Since Bid Manager already contains thousands of rules that drive the size of the model, it's simply a matter of taking that data and running it through a tool to generate the BIM model. Today, these BIM models can be obtained by sending a copy of your Bid Manager file, or the BMF file, directly to Eaton Cares Shane Shook or Rob Danielson. Hopefully this presentation has given you some insight into this rapidly expanding technology called building information modeling. We also hope that when you're asked for BIM models, now you'll know exactly how to respond, regardless if it's a configured to order product or an engineered to order product. Thank you.
Thank you for listening to our Launch and Learn Building Information Modeling. Our Launch and Learn presentations are archived on Eaton's Consultant and Engineer page at www.eaton.com/consultant, where you can also find information on all of Eaton's electrical products and services. If you have any questions regarding this presentation, or if you have recommendations or requests for future Launch and Learn presentations, please email us at consultantsupporteg@eaton.com.